Welcome back 202. This is your lab final short video, but this one is not going to be on your lab final if you're in the summer of 26 for any of the summer 26 classes. So someone asked me to do this specifically. So first of all, I'm going to talk about this dual run capacitor real quick. Okay, I know it's hard to see, but on this one here, I have 4 different connection points on this same thing. On this one here, I have 3 different connection points, and they're all the same. And then on this one here, I have 2 different connection points, and they're all the same. Well, these 3 things are different places on the capacitor. Not always. Used to be, but not always. You can count on this. The one with the most tabs sticking up is common. The one with the least tabs sticking up is fan. And the one in the middle is for run. Okay, your run leg. So, that may not always be that way on every capacitor, but it should be. They ought to make a law, making that the law. But anyway, so if you want to know for sure, read the side of your capacitor where it says fan and C and Herm or whatever, and there you go. All right. So now we're going to do the running capacitor check and calculation to see if the capacitor is up to snuff. We've already got a call for cooling on, but I don't have a call. Uh-oh, I know why. It's from the last video. Good thing this wire can touch anything. Nice. We got a call. Okay, but I have no high voltage coming into my machine. So the capacitor has 0 volts on it right now. And now it's got something higher than 0. This is a 200 and, I forgot what it was on this one, 208. Yeah, the next one's 240. This one's about 208. Okay, this is 208 volts coming into this one. Okay, no problem. I got 208 volts coming in from the power supply. This is everything from the power supply. All right? Now, on these capacitors, I'm going to check just the fan right now. So, I want to measure the voltage from the common, which is the power coming into the capacitor, to the fan, which is the power going out to the fan motor. I guess you could say it like that. And I have how much?
10.5.
10.5? Oh, I'm in the wrong place. Oh, I slipped off. I slipped off on the common. Sorry. I got, how about 321 and a half? I gotta write that down. Okay, I could have done this at the same time, but I didn't. For that same wire, not the common wire, for the same wire, I need to get an amps on it. So I've got it on amps. The same, I'm doing the fan. What's the amps on the start winding of the motor you're doing? I'm doing the fan motor. So I'm gonna clamp it around here, hold steady. I got 0.63 or 64. Okay, so amps, 0.64 amps. Okay, then I can do my calculation. What is the calculation? Okay, it's all over the internet. If you want to see a better video than this one on that takes a little longer, go to, well, you can go to AC Service Tech, or the one I like more than that for this one particular thing. Both of these are great places to go. is HVACR school with Brian Orr. Okay, so here's the calculation. I'm going to take the amps times 2,652, that whole thing, and I'm going to divide it by the voltage. So I've got 0.64 amps times 2,652 divided by 321.5.